Hi, welcome to the fourth unit of Natural Resource Management. In this unit, I am going to talk about water resources. Water resources are sources of useful water or potentially useful water. Earth is having a huge amount of water. It is estimated that Earth is having 1.4 billion kilometers cube of water, and this amount of water in Earth is remaining constant. And it exists in different forms. It can be the atmosphere in the form of water vapor or clouds, or in the surface of earth in the form of rivers or lakes. We have underground water or groundwater, which is under the earth's surface. And finally, we have oceans, and oceans hold a huge amount of water. About 97% of earth water is in oceans. And this is the representation of water on earth. 97% of water is in oceans, and 2% is in glaciers in the form of ice. And finally, we have 1% as river water, lakes, and in groundwater. So, water cycle. Water cycle is the way in which water changes its forms, and it is globally distributed. And water exists in different forms, in liquid form, in the vapor form, and the ice form. And the water cycle involving in the exchange of energy. And schematically, we can see the water cycle here. So water evaporate from the ocean, from the rivers, from lakes, from the animals due to the respiration of animals, plants, and every living organism. It is evaporates and it forms clouds, and the clouds condense and form precipitation in the form of rain or in the form of snow. Once the precipitation reaches the ground, it can be infiltrated into the ground and contribute to the building up of the groundwater, and a portion of it will be uh, go to the nearby water bodies in the form of runoff, and this nearby water bodies, maybe rivers or lakes, finally end up in ocean. So that's how the water cycle works. And one important parameter of in the water cycle is residence time. Residence time is the measure of time, how much time a water molecule spend in a particular reservoir. We can say that the ocean is a reservoir of water, the clouds, the atmosphere is a reservoir of water, the groundwater is a reservoir of water, the river is a reservoir. So the table shows the average time, residence time in different reservoirs. If the water become an ice sheet of Antarctica, its residence time is 20,000 years. That means if a water molecules become Antarctic ice molecule, it will be in the Antarctica in the form of ice for an average of 20,000 years. After the 20,000 years only, it will become it will be a part of another reservoir, maybe coming to the ocean or coming to the atmosphere. For oceans, the residence time is 3,200 years, and for rivers, it's only 2 to 6 months. In the atmosphere, the residence time is 9 days. After 9 days, a water molecule in the atmosphere will transfer to another reservoir. Maybe it will precipitate and it become the rain, and it will end up in groundwater or in the rivers. So that's how it's work. So what what I really want to say is, like, the amount of water in the earth is constant, but the human activities, especially which leads to the climate change, it actually disturb the water cycle. So what disturbance it is causing is, like, the residence time will change. For the Antarctic ice, the residence time was huge, but due to the human activities, there is an increase in global temperature, which leads to the decrease in the residence time of water in the Antarctica, and it leads to the increase the precipitation, increase the evaporation. So all these are disturbing the water cycle. So human activities do not actually leads to the loss of water. The amount of water in the earth is constant, but it actually, like, it increase the flow of this, like disturb the flow of water cycle. So here is a representation of water cycle, especially in the urban areas. The evaporation occurs, the condensation also occurs, but the thing is that the infiltration of water into the ground is less because of the constructions and everything. The amount of water which actually infiltrated into the groundwater will be less, so the groundwater table will be low, then the runoff will be high. So much of the water which came in as a part of precipitation will be run off into the nearby water bodies. So we use water for various purposes, and the demand of water is increasing day by day. We are using it for agricultural purposes, for industrial purposes, and for domestic uses. And the thing is that we do not have enough water to satisfy our water needs. Uh, at the fact says 40% of global population is in water scarcity, and 70% of natural disasters are caused by water related natural disasters. So as the population increases, the population number increases, the demand for water is also increases. Industrialization also causes the increased water demand, and we do not have enough water to satisfy our water demand. We use water for different purposes, and a major use of water is for agricultural purposes. So to like make our crops, and for the poultry and the livestock, we need water. Huge amount of water is used in agriculture, and second largest consumer is industry, and 10% is used for domestic uses, and finally 3% is considered as the evaporation loss from the reservoirs. The water stress occurs when water withdrawal substantiate a large share of renewable water resources. So the measure of water stress is how much amount of water we are using and how much share of the renewable water we are using. So we have renewable water resources. Water itself is a renewable resource. But if you are using a huge amount of water, amount of this renewable resources, it will deplete slowly. So the water stress uh, can be represented as the amount of water we are actually withdrawing from the reservoir or from the source. If you are withdrawing only 10 percentage of the like water resource, withdrawing 10 percentage of capacity of the water resource, we say that we are, it is in a very low stress scenario. But if you are like withdrawing 40 to 80 percentage of water from the natural resource, the thing is that much of the water is already taken, so the capacity, renewable capacity of this resource will be lost. So we say that that is high stress area. If you are withdrawing more than 80 percentage of capacity of a renewable resource, we say it's extremely high stress area. So if you take a look at the Indian scenario, we are not good with water. We have huge water demand, but in the northeast we can see that there is water stress is less. But in the northwest region, that's Rajasthan, Gujarat, Himachal Pradesh, Punjab, so these areas, the water stress is huge. More than 80% of water we are taking from the renewable resources, and this resources will be depleted very soon. In case of South India, the water scarcity is much in areas of Tamil Nadu, but in Kerala, we are in a much better situation. But some of the areas are under severe water stress. So there is an immediate need for conserving these water resources and make sure that we will have enough water to satisfy our all water demands. And we have different water resources. The water resources can be a freshwater resource, which includes rivers, lakes, and groundwater. And we have wetlands. Wetland can be with the freshwater or the seawater. Estuaries are a combination of mixture of seawater and freshwater. And finally, we have marine water. Thank you.